Today is day 8 of Advent of Code, and today's challenge is called Treetop Tree House. So let's go to Advent of Code and let's get started. The expedition comes across a peculiar patch of tall trees all planted carefully in a grid. The elves explained that a previous expedition planted these trees as a reforestation effort. Now they're curious if this would be a good location for a tree house. First, determine whether there is enough tree coverage here to keep a tree house hidden. To do this, you need to count the number of trees that are visible from outside the grid when looking directly along a row or column. The elves have already launched a quadcopter to generate a map with the height of each tree, the puzzle input, for example. So this is a 5 by 5 grid of numbers. Each tree is represented as a single digit whose value is its height, where 0 is the shortest and 9 is the tallest. A tree is visible if all of the other trees between it and an edge of the grid are shorter than it. Only consider trees in the same row or column. That is, only look up, down, left or right from any given tree. All of the trees around the edge of the grid are visible. Since they are already on the edge, there are no trees to block the view. In this example, that only leaves the interior 9 trees to consider. The top left 5 is visible from left and top. It isn't visible from right or bottom since other trees of height 5 are in the way. The top middle 5 is visible from the top and right. The top right 1 is not visible from any direction for it to be visible. There would need to be only trees of height 0 between it and an edge. The left middle 5 is visible, but only from the right. The center 3 is not visible from any direction. For it to be visible, there would need to only be trees of at most height 2 between it and an edge. The right to middle 3 is visible from the right. In the bottom row, the middle 5 is visible, but the 3 and 4 are not. So, with 16 trees visible on the edge and another 5 visible in the interior, a total of 21 trees are visible in this arrangement. So, consider your map. How many trees are visible from outside the grid? So, we will now grab our puzzle input. We will copy this and we will put that into our input file. So let's start off with a for each var line in input. So we're going to have our grid as a list of ints. So when we go through the input, we'll start off with index 0 of the outer list. Then on the inner list, this is where we'll add the numbers in. So here we'll have var row equals new list of ints. Then for the line, for each var tree in line, row dot add convert dot int 32 tree. So this will add all the trees to a row. And then when we've gone through this, we will do grid dot add row. So this for each will build the grid. We'll then do int trees visible equals 0. And the math for the amount of trees visible is, so trees visible. So we'll do plus equals grid dot count times 2. The count of grid will be the amount of trees in a column. So we do times 2. So we have one column here, one column here. We'll then do plus grid 0 dot count times 2. So for this we are grabbing the first row, getting the amount of trees on that row, then timesing by 2. Then we will do minus 4. Based on the method here, the corners of the grid are going to be counted twice, so we need to remove 4 from that. So now that we have recorded that, we will figure out which trees are visible or not. So we will start off by going row by row. So for int row equals 1, row is less than grid dot count minus 1, row plus plus. So go grid, it's going through each row. So you skip the first one because they're all visible. Then you go to the next row. Yep, that's correct. Then we want to go through each of the trees in that row. So for int tree equals 1, tree is less than row dot count minus 1, less than minus 1 to avoid the edges as those are visible, then tree plus plus. So what we need to do next is, actually we'll rename tree to column because that's a bit more accurate. So we've got the row and then the column. So we now have the coordinates of a tree. We then need to grab the current value, so int current height equals grid row col, and then from that position we need to go, so if it's on the edge here, so number 1 you check to see if this one is a lower value than it. If it is, then it's visible. Then you can go check to see each direction, iterating through the values. So we'll have a left check, right check, up check, down check. And we will have bool is visible equals false. And we'll have checks all throughout. If is visible, true visible plus plus, continue. Same here, and then finally down here, but I don't need to continue anymore. So for the left check, it will be for int left col equals col minus 1. Col is greater or equal to 0, col minus minus. Then we will do if grid row left col is less than. Okay, no, we can't just do if it's less than, because it could be there's a tree that is greater than. Might have changed this to true. Start off with tree, and then if a tree is greater or equal to current height is visible equals false, then we can break out of this loop. It'll go to here, it won't plus, and then we'll go to the right check. Yep, that's how we'll do it. So now I'll do this for right col. Oops, I accidentally had col for all of these. Needs to be left col, and then this one needs to be right col. So now if is greater than or equal to is visible. And now for the up and down checks, we'll be doing the row instead of the column. So do up check here, up row is row, whoops, it's row minus 1. So up row greater than or equal to 0, up row minus minus. So we put the up row here, col into here, and do the same thing there. And then for the down check, it'll be plus 1 less than grid dot count, and then down row plus plus. So I think that's all that needs to be done to check it. So if it is not visible, it becomes false. Oh yeah, then we need to reinitialize this value, because the way we're checking things is we're under the assumption that it is visible, and then we have to verify that it's no longer visible. So put these onto here. I'm sure there's a prettier way to write this code, but I can't be bothered figuring that out. Okay, so let's give this a print and see if it's working. Okay, let's run it. Convert does not contain a definition for int32. Oh my bad, it's convert to int32. And then line 22, there's apparently an error. Oh whoops, this is meant to be grid, then row dot count, and then the name up row does not exist. Line 65, that's probably down row. Yep. Okay, let's change that. Now let's rerun it. Okay, apparently 1,779 trees are visible. Let's see if that's correct. Okay, cool. So that's part 1 complete. Now let's go on to part 2. Content with the amount of tree cover available, the elves just need to know the best spot to build their tree house. They would like to be able to see a lot of trees. To measure the viewing distance from a given tree, look up, down, left, and right from that tree. Stop if you reach an edge or at the first tree that is the same height or taller than the tree under consideration. If a tree is right on the edge, at least one of its viewing distances will be 0. The elves don't care about distant trees taller than those that found by the rules above. The proposed treehouse has a large eaves to keep it dry, so they wouldn't be able to see higher than the treehouse anyway. In the example above, consider the middle 5 in the second row. So this one here, looking up, its view is not blocked. It can see one tree of height 3. Looking left, its view is blocked immediately. It can only see one tree of height 5, which is right next to it. Looking right, its view is not blocked, so it can see 2 trees. And looking down, its view is blocked eventually. It can see 2 trees, one of height 3, then the tree of height 5. A tree's scenic score is found by multiplying together its viewing distance in each of the 4 directions for this tree. This is 4, found by doing 1 times 1 times 2 times 2. However, you can do even better. Consider the tree of height 5 in the middle of the 4th row. So down here, looking up, its view is blocked at 2 trees by another tree with a height of 5. Looking left, its view is not blocked, it can see 2 trees. Looking down, its view is also not blocked, it can see 1 tree. Looking right, its view is blocked at 2 trees by a massive tree of height 9. This is a scenic score of 8, 2 times 2 times 1 times 2. This is the ideal spot for the treehouse. Consider each tree on your map. What is the highest scenic score possible for any tree? Okay, that seems easy enough. So we will grab the code in part 1 as a starting point for part 2. We'll quickly change the running function part 2 and we'll paste it in. So instead of visible trees, we will have scenic score. So we have the same thing here, building the list, and we will do the same thing here, except we will now be doing all rows and all columns. So we will have int left equals 0, int right equals 0, int up equals 0, int down equals 0. So we can remove these is visible checks, as these are no longer needed. And inside here we can do left plus plus, and then if it's greater or equal to, it will just break from it. Then the same thing here, right plus plus, if it's greater or equal to, break, up plus plus, break, and then down plus plus, break. At the bottom here, we'll do int, what do we name this one? Best scenic score. Int scenic score equals left times right times up times down. Then if scenic score is greater than best scenic score equals scenic score. And then we can just print out the scenic score. So let's run that and see if it works. Okay, it seems like I forgot a few trees visible and is visible values, so let's remove that. Ah, my bad, accidentally kept these. And remove the break, so we'll put these back in. And where is the tree? It's visible. Okay, yeah, don't need this anymore. So now let's run it. Apparently the best score is 172,224. So let's submit that and see if it's correct. Okay, cool, that was correct. So that is day 8 of Advent of Code completed. If you like this video, make sure to like and subscribe so you don't miss out on any new videos that are done for Advent of Code 2022.